The final video for lesson 7, dealing with quadratic equations and discriminants for module 3 here. So we're going to look at these directions here. On the line below each graph, state whether the discriminant of each quadratic equation is positive, negative, or equal to 0. Then identify which graph matches the discriminants below. Okay, so we want to first describe whether the graph has a discriminant that's positive, negative, or equal to 0. Now, how are we going to do that, right? If you think about this, how have we used a discriminant in the past? Okay, the discriminant tells us how many solutions there are. Either it's possible to have 2 real solutions, 2 imaginary solutions, or 1 real solution. Okay, and how do we know how many solutions we have, right? It depends on whether the discriminant is greater than 0. That's 2 real solutions. If the discriminant is less than 0, 2 imaginary solutions. And if the discriminant is equal to 0, that means 1 real solution. And solutions to what? What are these solutions? They're solutions to the quadratic equation that we are given. Okay, and specifically, it's when that quadratic is equal to 0, right? We want to know when it's equal to 0, right? We rewrite them all so they're equal to 0. Okay, so let's take a look here at this graph. When is this quadratic equal to 0? Okay, here is when the quadratic is equal to 0, right? That is 0. That's when y is 0, right? How many times does that happen? How many times does this parabola here intersect the y-axis? Just 1. So what would we expect that discriminant to be then? If we only have 1 solution there, the discriminant, or sorry, we're supposed to say equal to 0. So since we have the discriminant here would be equal to 0. Okay, let's hold off on this one right now because we don't really see any intersection. Well, actually, no, let's go ahead and do this one. So what about this graph? Where does it equal 0? It never equals 0. Okay, now we don't have an option here for never equaling 0, right? We only have 2 places where it equals 0, right? 2 real solutions. We have 1 real solution, 1 place where it equals 0, and we have 2 imaginary solutions. Okay, and that's where this situation is. It's 2 imaginary solutions because if you look here, right, there's no real places where our graph crosses the x-axis, right? It never does. And so in this case, we have the discriminant would be negative. No real solutions. Okay, what about this one? How many solutions do you see here? Again, look at the x-axis. How many times does it cross? Twice. So 2 real solutions. That means our discriminant is what? Greater than 0. I guess I'll go ahead and put the 1 real solution there. Okay, and then finally here, how many real solutions do you see here? Well, it crosses twice. So same thing. Discriminant is greater than 0. 2 real solutions. And now we want to match the graph with the correct discriminant. So just evaluate all these discriminants here and see what values you get. Take a couple seconds and go ahead and do it. Okay, so this discriminant, when you evaluate it, should give you -4. This discriminant here, when you evaluate it, discriminant B, will give you 32. This discriminant here, when you evaluate it, will give you just 16. And this discriminant here, when you evaluate it, will give you 116. Okay, so I think I messed up one of my calculations here. Yes, this one's supposed to be 0, not 32. There we go. Okay, so what matches with what here? Well, here is the only negative discriminant, which would correspond to the no real solution situation. So that means this is graph 2. Okay, here is the 0, so that means discriminant is equal to 0, so that's the 1 real solution, so that would be graph 1. And then for these two, it's a little bit trickier to determine. So in this case, though, it has to do with Look at the direction the graph is pointing, though. Here the graph is up, which means that a is greater than 0. So b squared minus 4 times a is negative 1 here. It can't be 4 then. Here, this one, b squared minus 4 times a is 1, so that's a positive a value. So that means 4 is the graph, and since 3 is opening downward and the a is negative 1 there, that means 3 is that graph. All right, so that concludes our lesson there, and we'll see you next time. Bye.